All right, hello everybody and welcome. This is 6.5 from the Holt-McDougall Algebra curriculum, and in this set of videos we are going through 6.5, which is solving special types of linear systems. Those two special types are outlined right here. That's going to be a system of equations with infinite solutions and a system of equations with no solutions. So those are the two things that you will be learning in this set of videos: systems with infinite solutions and systems with no solutions. So let's go ahead and get down to our first sort of little bit here. So first of all, we got to talk about number of solutions. So we have said in previous videos in this section that a solution is an intersection point. It is where the two lines that we've looked at cross, where they intersect. So something with one solution will have two lines and they'll cross at some point, right? That point right there is where they cross. So this is one solution, and notice on these that they have different slopes. If something is going to cross, if two lines are going to cross, they have to have different slopes, because as you will see in this case, something with no solutions means that they do not cross. And the only times two lines never cross is when the slopes are the same. And we have a special word for when two lines have the exact same slope. That word is parallel. So when two lines are parallel, their slopes are the same, therefore they have no solutions. And finally, the last little set here is infinite solutions. Infinite solutions means they have to intersect an infinite number of times. And the only way that can happen is if you have a line that coincides with another line, meaning there is a line right on top of the other line. Notice how I'm drawing a second line on top of this one, right? With a little bit further. These two lines coincide. They have the same slope and they have the same y-intercept. They are in essence the same line. And that's why they have an infinite number of solutions, because one line completely overlaps and coincides on top of the other line. Now, if we went outside of the linear systems here, we could make things have 2, 3, 4, 5 solutions, right? We can make a graph that goes like this, where it kind of comes down and like loops up a couple of times, and then has a line crossing through it. How many solutions does this have? Just count the number of times they intersect. 1, 2, 3, 4. This has 4 solutions. Again, solutions are the points where they intersect, and in sections 6.2 through 6.3 and 6.4, you learned a bunch of algebraic ways of finding this intersection point, right? So now we're just looking at these special cases. And that's all we've got for the first video. There's 3 questions to do on your Canvas lesson if you want to go back and do those real quick.